So we're going to go ahead and continue. So this is the Algebra 2 Unit 1 Equations and Inequalities tutorial part 2, starting on slide 14. So we learned about graphing linear our inequalities. Now we're going to go ahead and actually combine it all together for solving linear inequalities. The first step will be setting up our inequality, finding our solution, and then graphing our solution here. So the 3 steps, and they actually provide an example. So if you click on those little stars, they'll give you the example regarding this one. I don't think they mentioned this in example, but we're going to move on to the next slide, 15, and take a look at the question there. So early, we analyzed the revenue earned by the junior class at East High School from the discount card fundraiser. They had a goal to earn a profit of more than 10,000. So as I read along, I like to kind of highlight or make sure like we pinpoint some important information especially in any kind of word problem. It's always best to either underline or highlight the best, or not the best, the key information that we need, that is like included into our overall problem. So since the local area businesses are supporting the fundraiser, the only cost to the students is a production cost. So the profit from the cards is found by subtracting total production cost and from the total revenue. So when you think when you think of revenue, is how much money are you making by selling these cards only, and then you're gonna subtract by the cost. So I know here they're selling the cards, right? They're selling the cards and making money per card, but it does cost them a certain amount of money to make those cards. So think about it as as an investment of like printing the cards and then cutting them up or ordering it in a way. So it says each card costs 20 cents to produce. So that is our cost right there. And it is sold for 20. So they already gave us our cost. That is going to be our revenue. So in order to find the profit, you are going to do the revenue minus the cost. And this is going to set up to or equal to our profit. Now, I kind of messed up already there saying that it's equal to. Keep in mind, it is going to be an inequality. So let's go ahead and try to set that up. So keep in mind, the revenue is $20. So I can put my 20 here. The thing is, am I just making 20 automatically? It doesn't seem right. Because for every card you sell, you're making 20. So if I sell 5 cards and I sell them for 20 each, I get 100. What I'm doing there is multiplying, but what value would I represent the cards if we don't know exactly how many? So if we kind of continue on to that question, it says, if the class sold C cards, the inequality that represents a profit goal is. So we're gonna add the C value there because we don't know exactly how many cards were sold. Let's talk about the cost. So we already checked that one off. Our cost is 20 cents. So right here we have 20 cents, but it also says each card costs 20 cents. So for every card made, 20 cents are used. Don't forget the minus sign. Now for the profit, it does say that we need to make more than 10,000. So if you think about it, we're gonna go ahead and use our greater than symbol for more than 10,000. 1, 2, 3. Okay. So we already have our inequality set up. That looks like it's gonna be that second one right there. 20C minus 0.2C. So that 0 could be included. Then again, it's just adding extra space to it. So it'll be minus 0.2C greater than 10,000. So it says, so here we follow those steps in that previous slide 14. We set up our inequality, we solve it, and then we graph it. Here they are asking us to see if 520 cards did or did not meet their goal. So when we take a look at that, we can kind of simplify this already. We can the left side of the inequality, 20C minus 0.2C, is they're like terms because they both have the same variable there. So they're like terms. We can combine those like terms. So we do 20 minus 0.2, that is 19.8. So that's 19.8C, and that is going to still be greater than 10,000. So they are giving us a value here. It says that this year's class sold 520 cards. So they actually gave us our C value. Let's go ahead and plug in our C value to see if that does generate more than 10,000. So what we're going to do here is, well, actually, you're going to take this step. You're going to go ahead and solve by plugging in, instead of C, you're going to replace it with 520. So you'll have 19.8 times 520. Now, whatever answer you get here, if it is greater than 10,000, they did meet their goal. If it is less than, if it's not true. So when you put in that number and you find out that it doesn't work, right? And maybe the value isn't greater than 10,000. That means that they did not meet their goal. So go ahead and enter that. And I'm going to actually move into the second part. So it says, so again, you're going to fill out if they did meet their goal or they did not meet it, because they sold more than blank cards. So this one is actually part of the solving. So what I'm going to do is that you should have already kind of solved for that. And remember, don't forget to like pause the video when you're solving this, because I'm going to continue on. But actually, I'm going to put that 0 here. We're going to solve this. So instead of replacing this with the C value, yeah, I should erase that. I'm going to go ahead and solve for C. So one thing I want to do is I want to isolate that variable C. Right now, it's next to 19.8. Keep in mind that this is being multiplied. So in order to remove that 19.8, I'm going to do the opposite of multiplication. I'm going to divide. So I'm going to divide by 19.8 on both sides. And let's see, this already cancels out. We have our C value. I'm going to try to squeeze it in. We keep our same inequality symbol, so that it will be greater than. And let's do 10,000 divided by 19.8. We C is greater than 505 point, I'm going to round it to 2 decimal places. 505.05. Now, when we are considering the value here, you cannot sell 0.05 of a card. It's not possible. So we can only consider it as in whole numbers. So see if you, so we think about it here, I'm going to draw my number line here to graph the solution here. So this is going to be 505.05. And this line right here, let's just say that that's the 505. So to follow this, right, to graph the solution here, it is going to be a open circle, and C must be greater than, so it's going to be shaded off to the right. That's when it comes to graphing the inequality, the linear inequality solution. Okay, so when we, so their goal, so they blinked their goal because they sold more than, well, what value did we get when we end up solving here? 505, so it's going to be 505 cards there. So I know the inequality symbol is a little bit weird because 505 is here and we got our answer as 505.05. But again, when we're considering whole numbers only, the decimal kind of gets ignored. I don't want to say like we don't consider it all. So in certain cases we will consider it, but here they're kind of just like, let's brush that off to the side. Also, if you look at the values, 520 is a possibility, but at minimum, right? 505 needs, or you need to sell more than 505 cards. Here they're saying more than 520, more than 556. Those aren't values that we got when we answered. It's 505. So let's go ahead and continue on to slide 16. So quadratic equations and their inequalities. We are going to be solving quadratic equations, but instead of having equal signs, they are going to have a greater than, less than, uh, greater than or equal to, less than or equal to inequalities. So let's take a look at slide 17. So keep in mind, in order to find the revenue, you are going to multiply the price that you sell your item for and how many items you sold. So again, like if you sell $2 bracelets, the price is $2. Say you sell 10 bracelets, you're going to put the value there 20 or 10. Sorry, I'm getting ahead of myself. 10. The revenue is 20. So this is a still continuation of kind of that warm up that we started with about the fundraiser. So here it looks like they sold 20, the price is 20 cards and they sold 520. They made a profit of 10,400. The next year they're using the values of, well, let me go ahead and kind of continue reading on over here. So next year's junior class from the East High School is already thinking about when it will be their turn to have their discount fundraiser. In fact, they're considering on decreasing the cost of the card in order to sell more cards and increase the awareness of an annual fundraiser in the community. So if you think about it, they're kind of, you got to think of all this as like you're running your own business. If sometimes, especially in quadratics, they will show you your maximum amount of profit when you consider the cost and how much you're selling. So say you're selling $20 t-shirts, or actually now they're like 30. So let's just say you're selling $30 t-shirts. You have a good amount of people that are buying it, but you want more people to buy shirts. So what happens if you decide to say, all right, let's have a sale and let's throw a discount there. So instead of 30, let's drop it down the price to 25. Then you actually might get more people to consider on buying your material. You might actually make more money from dropping your price and instead of having that price value so high or not, or from having it originally. So that's the same idea here. Now they decided for the cards, it says the students estimate for each $2 increase in the cost of the card, they will sell an additional 80 cards next year. So they're actually going to drop down the price. So if you look at this, this is how we end up forming a quadratic equation. Originally, the price of the cards is 20. They decide to decrease it 2 times, so increments of $2. So they drop the price one time, it's going to be 18. They drop the price again, it's going to be 16. Again, it's always going down by 2. Now, for everyone likes a sale, right? The less of the price, the more people that might consider on buying. So if originally it was 520 that was being sold at $20 at a piece, if you drop the price once by $2, you're going to get 18 people more interested in actually buying. And then it continues. That's why it carries that variable X, because for every single time that we drop the price, our amount of people that are going to buy it is actually going to increase. Here, we would multiply this all out by using, I like to call it banana method, or in other words, use distribution method to get this equation out here. And they decided to combine like terms inside the middle here. So that 1600x minus 1040x came out to 560x. And then from here, we're going to go ahead and continue solving it. So let's take a look at this on slide 18. So before we're going to take a step away to go ahead and actually cover how to solve for quadratic equations. There are a couple of different ways. One might be more straightforward than the others, but let's go ahead and take a look at each one here. And by looking at the examples down below as I explain it along. So the first one is square roots. If you have the variable here, they give us 3x squared minus 4 equals 44. So here the goal is, because you only have x squared there as your variable, you're going to do everything possible to isolate that x squared to get that alone. So the first thing I would want to do, x squared is attached to the 3. So I want to wait until the last part to remove that 3 away from x squared. Let's remove this minus 4. Everything in math does its opposite. So opposite of minus 4 is adding 4 to both sides. So we add 4. We will nothing happened to this 3x squared. So this will be 3x squared. This cancels, equal to 44 plus 4, 48. Again, we want to isolate just x squared. So now we can remove that 3. Keep in mind, what's happening between 3 and x squared is that they're multiplying. So we do the opposite of multiplication. We go ahead and divide. So we're going to divide by 3. That is going to isolate to have your x squared. And that's going to equal to, that is 16. 48 divided by 3. So now, again, this is why they call it the square roots, because you only have just the variable x squared. Sometimes you're going to have more terms where you have a term with an x squared and x. That's going to actually set us up for a different setup. So now we're still not done. I just want x. I don't want x squared. So how do I get rid of the square or that little 2? We take the square root of both sides. So again, everything in math has its opposites. The square root will cancel out the square. And I'm going to move it actually over here. This is going to be x equals, now when you take the square root of a value, you are going to have the positive and the negative there, because the square root of 16 is 4. If you think about it, 4 times 4 is positive 16. Negative 4 times negative 4 is also positive 16. So that is things that we need to go ahead and consider. Let's go ahead and take a look at the next one, by factoring. So when we are factoring, we are going to factor out the GCF as much as possible. So again, let's go ahead and take a look at this one right here. So this is negative 2x squared plus 4x plus 70 is equal to 0. Now, the only way to factor, and also when we go ahead and take a look at the quadratic formula, it is very important that our equations, or in this case, also including our inequalities, are set up equal to 0. So again, that's for the factoring and the quadratic formula. We want to make sure that we have that 0 there at the end, because if we don't, we need to make sure one side is equal to 0. So we're already good on that. It's equal to 0. We are going to factor out the GCF. So I try to look at each term, and the idea here is like, okay, negative 2x squared, 4x, and 70. Well, they're all divisible by 2, so let's factor out a 2. I personally don't like having a negative in front of the x squared. So I'm going to factor out a negative 2. So if I factor out negative 2, and that's exactly what they're doing over there. But again, I'm just explaining it step by step. So then here we'll just have x squared. And this is how I when you're factoring out a negative, all the signs will change. So this positive 4 will become a negative. Now it's not just 4 though, right? It's 2 times what gives you 4. That's your 2 here. So don't forget to bring down the variables if there are any variables. Again, the sign changes. Half of 70 is 35. The idea is that if I were to multiply negative 2 back inside this parentheses, I'm going to get the top part again, the same thing. But we're trying to break it down as much as possible. Now, this negative 2, I like how it's just sitting out there. We're going to leave it. Now, the inside, I like that there's just an x squared here, and I have 3 terms, x squared, x, and then this constant. That's telling me I can use the giant X. So I'm going to put the giant X here. Now, this also kind of originates from the quadratic formula where the value, so just focus inside those parentheses. The coefficient in front of x squared is an invisible 1. The coefficient in front of b, or like, do you see how it says ax squared plus bx plus c? The value in front of x squared is a, the value in front of x is b, the constant is just c. So the number outside of x squared is 1. The value outside of x is -2. So this piece, and this is your c. A, B, C. Up here for the giant X, you are going to include your A and C. So you're going to multiply your A value and your C value. So your A is 1, your C is -35. 1 times -35 is -35. Down here, you're going to just put your B value, which is just -2. Now, here you're going to give me two values that multiply. So this is the multiplying part. Multiply to get -35, and then down here is add to get -2. So we write out all the multiples for 35. I'm going to do it over here on the right-hand side. 1 times 35 works. 2 doesn't work. Neither does 3. 4 would not work. 5 and 7. So starting from 1, I work my way down using each numbers until I get a repeating pair. But in a different order, that's when I want to stop. So after 5, 6 cannot go into 35. After 6, it's 7. I already wrote down my 7 here for the pair of 5 and 7. So we can stop there. These are the only multiples for 35. Now, if I were allowed to add or subtract them, which one can give me 2? So again, I go through each pair. 1 and 35. If we add them, we get 36. If we subtract them or take the difference of them, it's 34. So that can't give me 2, so I can't use that pair. My only pair is 5 and 7. So actually, let's go ahead and write them there. So 5 and 7. Now 5 times 7 is 35, but I need -35. So one of them has to carry the negative. Let's just place it with 5. Keep in mind, either both values can carry the negative, or maybe only one value needs the negative. So I'm going to test it out. -5 times +7 is -35. -5 plus 7 is +2, not -2. So my negative didn't actually work there with the 5. Let's try it with the 7. 5 times -7 is -35. True. 5 minus 7 is -2. So that is true. So inside this parentheses, I'm going to use these values to rewrite this in what I have inside the parentheses. So my -2 still stays on the outside. Parentheses, so right here I have a +5. So that is my x plus 5. And then I have a -7, so that is going to be ax minus 7. So keep in mind, inside the parentheses got changed to x plus 5 times x minus 7. This is still equal to 0. Now, again, why did we break it down like this? Now, from here, if I were to divide by -2 on both sides, because keep in mind, all of these are being multiplied. So again, to get rid of it, right, you need to divide. If I get rid of this -2, 0 divided by -2 is still 0. So I can ignore that -2 for right now because I divided both sides by -2. This is my setup, because when we have it factored, we separate each factor. So x plus 5 is a factor, x minus 7 is a factor. We separate them and we set them equal to 0. So I take this x plus 5 and I said this is equal to 0. And I take my x minus 7 and I also equal that to 0. So then we solve them independently. So I want to isolate my x here. So this plus 5, to get rid of it, I do the opposite, minus 5 on both sides. And that cancels. That is going to be, oops, that's going to be x equals negative 5. And over here, we have this minus 7. So again, to isolate that x, we're going to add 7 to both sides. And once we're done, or we got rid of this, we have x equals positive 7. I know it overlaps there, but they also did it for you right here, a lot more cleaner compared to mine. So that is solving by factoring. Moving on to the next one, which is completing the square. So completing the square, just by looking at the equation or the setup of it, it looks a little bit kind of weird. When did they bring in the value of d, and so on? So let's go ahead and take a look at this one here. So actually, I'm gonna to give myself a little bit more space and discuss what's going on here. All right. So we are going to start out with the equation of x squared minus 8x minus 11. Oops, minus 11 is equal to 0. So remember, the important part for factoring and the quadratic formula is that I want to make sure that that is equal to 0. Completing the square doesn't follow that rule. So here I want to move my constant. So this setup is the same thing as over here for our quadratic formula, ax squared plus bx plus c. Your a is this 1 here, your b is that negative 8, your c is negative 11. You want to move the c value to the other side. So here we are going to move this minus 11 by adding 11 to both sides. So what I get here is this is just 1x squared, or x squared, minus 8x. And what I'm going to do, it's like I'm wondering, should I do it? Let me just rewrite it like this for right now. Equal to, because this cancels, 0 plus 11 is 11. So the idea here is that I'm going to focus on my b value, the coefficient of x, which is, if I look for my x, it's negative 8. The negative 8 is my main focus, where I'm going to divide it by 2 and then I'm going to square it. So let's go ahead and like write it out what I just said there. So let me do this in blue. So I take my negative 8 value over here. I'm going to divide it by 2 and then I'm going to square it. So let's do that first step. What is negative 8 divided by 2? Be careful with the sign. We should get negative 4. We still need to square it, so negative 4 squared is 16. So I'm going to take this 16 and I'm going to plug it in on both sides. So right here, I kind of purposely left that little space. I'm going to add 16 here. And I'm going to add 16 over here. Now what I can do is actually I can simplify this. This whole piece is going to go down to, now do you see here, they put that value of b over 2. So this piece I'm talking about right there, b over 2 was negative 4, right? Half of that b value is negative 4. So this is going to be parentheses x minus 4 squared equal to 11 plus 16 as 27. So now if you're not comfortable from that jump that I did there, you can do what we did for factoring, which was to do the giant x over here. So if I do the giant x, my x is not that giant. Oops. Because I'm going to run out of space, I'm going to move it over here to the left-hand side. Sorry for making your eyes jump. So remember, it's going to be my a value times my c value. My a value is 1. My c value is at 16. 1 times 16 is 16. And then I put down my b value, which is a negative 8. So we're going to write out the multiples for 16. So that is 1 times 16. That is 2. After the 1, it's 2 times 8 is 16. 3 doesn't work. 4 times 4. After 4, we kind of use a repeating of the same number, so we're going to stop there. Now, which pair can give you 8? Meaning you have to either add or subtract them. 1 and 16, if you add them, 17, so the difference would be 15. That's not 8. I have an 8 here. If I subtract 2, I get 6. If I add 2, I get 10. That doesn't work. So it's going to be this 4, 4. So again, you are allowed to add or subtract, especially when you have a negative value within. So here, negative are actually positive. You can play around with both of them. So right here, we're going to put 4 and 4. 4 times 4 is positive 16, but 4 plus 4 is not negative 8. It's positive 8. So do you see how in this case, not just one has to carry the negative, but they both have to carry the negative. So we, again, follow it along, right? Negative 4 times negative 4, positive 16. Negative 4 plus negative 4 is negative 8. So this will be set up as parentheses x minus 4 and then x minus 4. Because they're both the same, set up within the parentheses, that's how we came down to this right there, x minus 4 squared. Now the next part is that we're still not done because again, when you're solving, x needs to be by itself on one side. And here we have x, and technically in those, we have x in our parentheses. So what we need to do is actually get the x out of those parentheses and just leave x alone on one side. So the parentheses are locked with that square. So remember the opposite. So let me take a step back. Here, quadratic equations kind of use one method and another to they use each other in a way. So here, completing the square is going to kind of leave a little bit into did you see how we kind of did, we used a bit of factoring just to explain how I was able to simplify this from this line into this line here. Now, here, we're going to use kind of about a little bit of what we learned in that first one, square roots. We take the square root of both sides. And we are going to get, this is x minus 4, because the square root cancels out the 2, equal to, this is still going to have that plus or minus value. The square root of 27 will be broken down to 3 square root 3. Oops. Can I change that? No? Oh, there we go. 3 square root 3. And if you are worried about how we did that, the square root of 27, I'll do it right here. Square root of 27 can be rewritten as the square root of 9 times 3, because 9 times 3 is 27. But now this can be separated. The square root of 9, the square root of 3. Square root of 9 is just 3, and you're left with that square root in there because you cannot take the square root of 3, so it would be written as that. So that's just simplifying radicals. So then you want to get rid of that minus 4, so you're going to add 4 to both sides. And that is how they came down to x equals, this cancels. Here's our positive 4, so that plus 4. Plus or minus 3 square root 3. So that is solving by completing the square. It looks a lot more messier compared to what they wrote here, but I just want to make sure that and explain a bit like of how they actually came and broke down those steps and what they used. Let's go ahead and take a look at the quadratic formula. So the quadratic formula, again, it's one of those rules that applies where you need to make sure it's equal to 0. Everything else needs to be on one side. So if we take a look here, they have the equation as 2x squared minus 3x, minus 3x plus minus 8 equal to 0. So the first thing, if you are going to solve with the quadratic formula, you need to identify your a, b, and c. So if it is in this setup where you have x squared, x, and a constant, you just take a look at the coefficients. So here's your a, here's your b, and here's your c. If there is a minus or a negative symbol, you are going to take that value as a negative. Or especially here for this minus 3x minus 8, it is not just 3, it is negative 3. So now that you know your values, they even wrote it down for you right here. Your A is equal to 2, your B is equal to negative 3, and your C is negative 8. This is how I would write out the setup. So based off of this formula right here, I would write parentheses for each of those variables of A, B, and C. So here I have X equal to, I have a negative, I want to place my B there. So I put parentheses, plus or minus the square root. I am going to put B squared minus 4. There's my A, there's my C, all over 2, and then there's my A. So then I just replace it. So by using that same formula, I know I need to put B here first, which is negative 3. Another B again, so negative 3. The next parentheses, it would be minus 4A. A is 2. The next letter is C, which is negative 8. I hope you can read that. That's negative. And then 2A, or your A here is 2. Then you solve by breaking it down step by step. So I like to break them up into like little pieces, because it can be, when you have a lot of numbers, it can be a little bit overwhelming. So what I like to do is I'm going to break them up by like breaking them into little pieces. So I'm going to do the outside piece right here first. Then I'm going to take a look at this. And I'm just adding up, not random colors, but just so we get an idea of how I broke these up into pieces of how I would simplify this down. Because again, when you try to do it all at once, there's room for error, especially, or like I said, it can be just, it's hurting our eyes, but I promise you it's just it gets simpler. So right here I have let's focus on that pink section. Negative times negative 3 is positive 3. So I have x equals 3. Keep that plus or minus symbol. Let's keep the square root there. Oops. Negative 3 squared, we get positive 9. And here in that yellow section, I'm going to take that minus 4 as a negative 4. So negative 4 times 2 is negative 8. Negative 8 times negative 8 is positive 64. So I have a positive 64 plus 64. And then down below, 2 times 2, we get 4. See, wasn't that not too bad? Now, again, we still we still want to focus inside that square root by adding 9 and 64 together. So if I rewrite this, I'm going to get 3 plus or minus the square root of 73 over 4. So if you're able to break down the radical, kind of like what we did in completing the square, we are going to want you to simplify the radical as much as you can. In this case here, we can't do much more there. So your final answer is 3 plus or minus the square root of 74 divided by 4. So in some cases, it actually, the quadratic formula, if you identify properly your A, B, and C, you can kind of just straight jump into it. I definitely recommend writing out that formula. Pretty much all these that we covered, right, that you were kind of like following along or writing down in your notes, it's best to always practice, right? Sometimes you're not going to get it on the first try, and what we need is just a little bit of practice of understanding those rules, because quadratic has a broad range of like quadratic formula is like I want to say it's like universal for all the quadratics, but maybe instead of using the quadratic formula, factoring might be easier using the giant X. Or maybe I want to use the factoring and use a giant X, but it doesn't work because I can't find those pair of values that work to multiply for the number and add or subtract for that number. So then you would have to go into the quadratic formula. So I have some students that I work with that they tend to lean towards more depending on the quadratic formula. Again, it's up to you which one you like. But again, will all these methods work? Not all the time. I think the least favorite was completing the square, but that's just all from what I've heard feedback wise. Um, so in some cases, square root might be just like straightforward, but in other cases, again, you might want to use the factoring. But if you're not comfortable with factoring and you like the quadratic formula, you can use a quadratic formula. Again, the super key part is identifying A, B, and C properly. So let's go ahead and take a look at this one on slide 19. Um, so that now that we did see those different ways of solving those quadratic formulas, we want to go ahead and take a look at this one where this is actually the setup on slide 17, if I remember. Yeah. So this is the setup that they did for us on slide 17 that they actually want us to solve, now kind of getting exposed to a little bit of it. So here, let's take, well, I take a look at them. They're all very, very large numbers. Probably not what I would want have jumped into straightforward. But let's see if we can set something equal to 0. And I think that's what they're going to do here, because you can, from what I'm looking at, I have 10,400 here, 10,400 here. I want to cancel those out. So what I'm going to do is I'm going to subtract is 10,400 on both sides. And they're actually going to cancel out very nicely, which we like. So this is goodbye, goodbye. So what happens if it cancels out? Like, what value would I place there? I'm going to place 0. So nothing happened to the negative 160 x squared. So let's go ahead and put that here. Plus 560x. And that cancels, equal to, that also cancels, so we're just going to put 0 here. So it actually simplified our equation a lot more nicer than what we would by just looking at it before. So now we want to simplify this as much as we can. So by subtracting and getting it equal to 0, we can go ahead and factor out the GCF for both of those terms. So by taking a look, let's see what we can factor out from here. So let's see, for each, I want to factor out a negative for that 160, and 160 and 560 is, I know I can take out a 0, so I'm gonna, and the way what I mean by taking out a 0 is take away a 10 from there. And 16, and if I want to just focus on those two digits there, 16 and 56, I know 16 and 56 are both divisible by 8. So let's just factor out a negative 80. So by factoring out negative 80, again, the signs change because of that negative. Negative 160, this is another way to, like, when you're factoring and you found your GCF, negative 160 x squared divided by negative 80 is positive 20, or positive 2, sorry, 2x squared, minus, because again, the sign change, 560x divided by negative 80 is actually negative 7x, equal to 0. So there, well, actually, what I did also, I kind of goofed a little piece here. They both terms have an x. I can factor out an x as well. So if I factor out an x, this is no longer x squared, and then this is just 7 there. So when you remove an x, x squared will just be x. That x got removed, so it would just be negative 7. So let me write this over here. So we have negative 80 x parentheses 2x minus 7 is equal to 0. We can actually compare notes with on and Mentum here to see if we kind of got the same thing. So if I click over here on this orange button, they also, it looks like they also got rid of the 10,400 to make sure that's equal to 0. And the next part is they also factored out negative 80x. So I know with these large numbers, you can break it down as much as you can. You know, I kind of just jumped into it when I'm analyzing, like, oh, they both end in a 0, so we can take out a 10. They're 16 and 56 are divisible by 8, so that would be 80. If when you're breaking it down, you can say you didn't have a good idea, you just wanted to start with 2 and work your way down to factoring that also works as well. So here, what we want to go ahead and do it is going to be considered what we did for factoring, where this is kind of like also has a set of parentheses. And remember, we separated the parentheses and set them equal to 0. So here it'd be, I'm going to move it up here to the top, negative 80x. So that's one factor. That is going to be set equal to 0. And we take the other factor, 2x minus 7 is also equal to 0. So here they separated and they solved x independently. So here for to get rid of this negative 80, they had to divide both sides by negative 80. X is still equal to 0. And then here they added 7 to both sides and divided the 2. That's how they got 3.5. Or if you solve it on your own, you add 7 to both sides. That is 2x equals to 7. And divide 2 on both sides. So 7 over 2 is the same thing as 3.5. So give me a second here to, okay. So yeah, we use the zero product property. That's just right here what we did in red. So it says, since X represents the number of $2 increases in the price of the card next year's junior class will have a revenue 10,400. If they decrease the price of the card 0 times or 3.5 times. So the idea is that the junior class, right, wanted to make more money by thinking that they can go ahead and drop the price of the cards to sell more. But if they didn't change the price, so that value, that first answer we got, or the first solution we got, is 0. If we decide not to change the price, we're probably going to have the same outcome as the senior class. Now, if we do it 3.5 times where we drop the price, we're still going to get the same amount as that senior year. Remember, because these are the juniors, they're trying to come up of a way to make more than that. So it says right here, if they decrease it 3.5 times, they put it back into that factored there. So 20, so the reduced price, right? They want to find that actual price of what if they decided to bring their price down from the card. So it's 20 minus 2 times the 3.5 times they are going to do those increments. So 2 times 3.5 is 7, 20 minus 7, the $13. So instead of selling the cards for $20, they're going to sell it for $13. So to increase awareness, they still meet their revenue goals. Next year's juniors will sell their cards for $13. So their goal is to make that 10,400. They can still make that goal if they sell their cards for $13 instead of 20. So let's go ahead and take a look at this one right here. So it says complete the square to find the solution of X. So I'm going to go ahead and help you out here, and you're going to go ahead and do the setup. So remember, this actually, they already moved your constant over to the other side. So that negative 13, to find this value, you need to find your B value, which is the coefficient in front of X. You're going to divide it by 2. So here we have our 14 is our B. So if you take half of 14, you are going to get what value there? Now, let me kind of go this way. I don't like the setup of it, but if you did get the value of 7, oops, 7, that is correct. Here, what you want to do is remember, whatever you do to want to find that value, uh, let me do it this way. X squared plus 14x is equal to negative 13. So that's we move the negative 13 over. I'm going to focus on that 14 and say we're going to take that 14, right? Remember, we're going to divide it by 2, and then we're going to square it. So we already divided by 2. That's how we got that 7 there. But what is 7 squared? So we should get 49 here. So it should be x squared plus 14x plus 49. So this, what I'm doing here is this step happens right before we get to this one right here that they're asking for. So this step has to happen first. So x squared plus 14x plus 49 is x plus 7 parentheses squared equal to, now you need to simplify this for me here. Negative 13 plus 49, go ahead and enter that value down below. Then it says the value of x that makes this equation true is blank and blank. So whatever value you get from me right here, right, you are going to take the square root of both sides after, right? So this is like so very similar to what we did in the examples over there. Take the square root. Your square root is going to most likely be a perfect square root, so don't have to worry about that. And then once you're done square rooting, you have to get rid of that 7 by subtracting 7. Now remember, when you take the square root of that number, make sure you take plus and minus of that value. So you'll have 2 separate answers, and then go ahead and enter those values down below. Moving on to slide 21. So it looks like they're going to give us a little bit of practice of those different ways that we solve for quadratics. Okay. Oh, I thought there was more to it. Okay. So the square of a number x. So the square of a number, so something is being squared and they're calling it x, is 16 less, so it's equal to 16 less than 8 times the number. 6 is 16 less than 8 times the number. So the number again is just x, and there's your 16 less. What is the number? So for this one right here, we are, this is our setup. X squared is equal to 8x minus 16. And what we're going to do, there's a couple of different ways that we can solve for this. You're actually able to use quadratic formula, or you can use factoring. Either one is going to work. Again, it just depends on which one do you want to. I'm going to help with the setup for both of them. That way you can use to whatever your likings. So, because actually factoring and quadratic formula do involve in like using your ABC value. So I'm going to help you set up for that. Remember, for those two that we're going to try to approach to solve this equation, we need to make sure that it's actually set up to equal to 0. Now, I don't have equal to 0 here. I have this positive x squared. I would like to keep that one there. So I'm going to move this 8x minus 16 to the other side. So this 8x here, I'm going to subtract 8x. And I'm going to move the 16 at the same time, add 16. And we're going to bring this over here as well. And we get the setup of x squared minus 8x plus 16 is equal to 0 here. So keep in mind, x squared and x can be combined, so you just have to write them side by side. This cancels, there's your 0. So if you identify your A, B, and C, right, It's already set up there. So if you look at the coefficients A, B, and C, you should kind of be able to go from there, either using the giant X method or the quadratic formula. So remember, the giant X does want to have A times C at the top here, and then its B value here. So then you're going to give me two values that equal to, well, I'll just write it there. So A is 1, C is 16, and your B is -8. So you need to find the pair that multiply to get 16 and add to get -8. Remember, once you'll have a setup like this, set them equal to 0, separate them, and find that answer there. So there should only be one answer. So in this case here, you might actually have the same setup. The other one is the quadratic formula again. There's your A, B, and C. You'll just plug it into this formula. So X equals negative, remember, B goes here, plus or minus the square root of B squared minus 4 times A times C, oops, all over 2A. If you break them down section by section, again, you should be able to solve you should be able to solve, and you'll get, again, just one answer there. So I'm guessing that in here, yeah, you're going to be able to simplify only down to one answer. So again, there's multiple ways. You can even try to solve this by using completing the square. So I think, again, that's why I like math so much, because there's more than one approach, especially for quadratics. But go ahead and work on that one on side 21. And again, don't forget to pause the video, because I'm going to be jumping into the next one right here on side 22. So quadratic inequalities. We got a little refresher, or we got a refresher for quadratics with equal signs. And you haven't noticed it, or did you notice that there wasn't really any inequalities there? The greater than, less than, greater than or equal to, less than, equal to symbols. Now we are going to involve it. It is going to be very similar to solving as if we had an equal sign, but with a little twist, especially when it comes to graphing the solution. So remember, in that setup where we have linear inequalities, quadratic inequalities, we're going to do most likely the setup, the solving, and then the solution of graphing it. But this changes a little bit here. So let's go ahead and take a look at this one right here on slide 22. They actually gave us an example here. X squared plus 5x minus 14 is less than or equal to 0. Let's take a look at what they did first. So it looks like they did solve, pretty much what they did here is that they replaced our inequality symbol with an equal sign. So they want you to kind of solve as if you were solving with an equal sign. And also, do you see, it's also set up equal to 0. We like it because they did factoring here. So with factoring, we can think about the giant X, right? My A value is 1 times my C value is -14. That's -14 here. And 5 down here. The multiples for 14, 1 and 14, 2 and 7, 3 doesn't work. 4, no, 5, no, 6. Yeah, those are our only pairs. 1 and 14 is too large to get 5, 2 and 7. So here's 2 and 7. I need a negative somewhere. -2 times 7 is -14. -2 plus 7 is +5. So right there, we found our values there, and that's what they came up with. That -2 is X minus 2. That +7 is X plus 7. Keep in mind, order does not matter. I could have rewritten it as X minus 2, X plus 7. We will still get the same thing. So here, that order of multiplying does not matter here. So they continue to solve. They got X is equal to -7 and X is equal to 2. Again, that's just by separating those factors. So X plus 7, right, is equal to 0. You subtract 7 on both sides. There's our answer of X equals -7. and x is equal to 2, they did that factor of x minus 2 is equal to 0. You add 2 on both sides. X is equal to positive 2. So let's take a look at their next step here. Uh-oh. All right. So the idea here is, here they brought it as an interval test. I think it's better with another type of picture. So what I'm going to do, let me erase this. So we know that we got our values as x equals -7 and positive 2. So what I'm going to do here, the interval test is also, in other words, of like they actually looked at this on a number line. Let's just say let's put -7 here, and let's put our 2 value here. And they broke them into 3 sections. This is from here to here, that green section, and then let's just say this is the blue section. And the idea is they wanted us to test out a value to see if this is true. So the idea, I should have also done that as well. So this blue area, they actually tested it out in this box here. And this green area was tested within this one. And this purple area. So the idea is that they didn't actually use the values of -7 or 2. Because if you think about it in a number line, for the purple box down here, they use the value of -10. -10 is in that purple area. Let me do it in red. So what they did is they used -10 to plug into the equation. So, and this is the equation that I mean up here. This, the one that we started with originally. So by plugging in -10, they got the value of 36, right? So they replaced -10 inside for x. 36 is less than or equal to 0. That's not true. That's why they wrote false there, right? Because 36 is not smaller than 0. So this didn't work. Now, in the green area, the number between -7 and 2, they decided to go with 0. Keep in mind, you don't have to use 0. Here, you didn't have to use -10. You can't use -7 because you're going to get that 0. You'll end up getting a value of 0. The idea is choose any number in that area. So between -7 and 2 in that green area, 0 is the more comfortable one. We like 0. So when we plugged in 0, we got -14 is less than or equal to 0, which is true. So this inside here, it actually worked. Now let's focus on the blue section. Here, you could choose, here they chose 10. I could have chosen 3. And here they chose 10. It was a false and it doesn't work in this area. I'm going to prove it to you with just using 3. So again, any value within that number line, as long as it's just not -7 or 2. I'm going to try 3. And instead of x squared, it's going to be 3 squared plus 5 times 3 is 15 minus 14. I should have just done, instead of 3 squared, I should just put 9. Sorry, no, I'm jumping a little bit here. Then it's less than or equal to 0. 15 minus 14 is 1. 9 plus 1 is 10. Is 10 less than or equal to 0? That doesn't work either. Here, they plugged in the value of 10. They got 136 is less than or equal to 0. It's also false. This side doesn't work. So it only works, or it's only true, between -7 and 2. So actually, I goofed this part because, so this is the part. So the idea is, because this is the only area that it works in, our final answer is between x, right, is between -7 and +2. So you will test out those values you're gonna use the number line, and the number line is gonna, if where I put those giant X's, I know it looks such a mess, but those giant X's means that area doesn't work. So that purple area, neither did that blue area work. Only the green area. So it's super important that you read it carefully because again, these symbols, right? It's X is between -7 2, so meaning it can be anywhere in that green area. The red, again, is just those points that I tested it out that are within the number line, but again, not the actual values. And let's go ahead and move on to slide 23. So again, we're following that same example that they gave us on slide 22, but they graphed it out for us. So they took the inequality symbol and they just took it. And remember how we like to take it as an equal sign? We took that quadratic and we actually graphed it. Here are zeros, which you'll find out like our solutions are wherever it touch. Our solutions for the quadratic equations are wherever they touch on the x-axis. So here, -7 and 2. And again, they tested it out kind of like as if I was using the number line. Here it's positive, and here is it when it's negative. But remember, when I broke them up into these little sections here, oops, which I'm gonna try to do right now. I think this, I don't keep the same color, I apologize. But I think this was blue, right? This was my little blue area in the number line. This was green between -2 and 7. So do you see how I'm following the same number line compared to the x-axis, not the actual like graph of those lines there? So remember, it would only work with that those values there if it's in the green area. So that's how they came. Oops, sorry. That's how it came down to that it's only between -7 and 2 where it worked. And then if you follow, I keep on clicking on the wrong tab. Sorry about that. So again, if we ignore it, right, it's only, again, the interval of those solutions between -7 and 2 only. I think I wouldn't graph the actual quadratic equation. I like the number line, kind of like what I did on slide 22, and we broke those into sections, and then any number in that within that color section that you have can be a value that you plug in to see if it's true or not. So maybe instead of me doing the giant X, I should have just put a giant F for false and T for true, and you only want to write down the interval of the true part. So let's go ahead and take a look at slide 24 here. So it says, now let's look at how we can model the situation of a quadratic inequality. The Junior Student Council of East High School wants to add a storage room to the north side of the building. They have a maximum area of 300 square feet for the new storage room. So maximum area, that's 300, that's it. We can't surpass that because that's the maximum amount that we can reach. There is no more space after that. They want the length of the room to be 5 feet longer than the width. What options do we have for the width of the room? So if this is kind of like our own little example here. So W plus 5 and W. Keep in mind that W plus 5 is that the length. So when you are looking at a rectangular prism, the length is kind of the longer side of it. So that this is the length here, and this is, let's just put W for width here. So the length must be 5 feet longer than the width. So that's why we don't know what the width is. So we're going to put W plus 5. Then we have the width here, which is just W. Now, again, this is talking about maximum area. So to find the area of any rectangular prism, right? This is my length. My W is still my width. We need to multiply. So we need to set up first our inequality symbol. So I think if we click on it here, they're gonna tell us our setup here, but we can kind of set it up ourselves to get that practice. So since we are talking about area, it is going to be the length times the width, and that gives us our sum area. I'm kind of setting it up for our inequality here. So our length is W plus 5. So I'm going to put W plus 5 times our width. And our area, maximum area is 300 square feet. I think I was saying 3,000. Was I? I'm sorry if I did. Our maximum area is 300 square feet, meaning we have to stay under that 300 or use up the whole 300. So I think if we match up they have the same thing. My W is written on the other side, but it can be switched over. And let's just go ahead and multiply. So what I'm going to do is I'm going to distribute that W on the outside into the parentheses to remove those parentheses. So why am I clicking on the wrong one? W times W will be W squared plus W times 5 is 5W less than or equal to 300. Now, here's the idea though. Remember when it came down to solving for them, we couldn't have that. We needed to equal to 0 somehow. So what I'm going to do is I need to set this up to equal to 0. And the idea is, remember when we were solving for quadratic inequalities, we ignore the inequality temporarily and we replace it with an equal sign. So that is what I'm going to do right here. Actually, yeah, I'm going to do this right here. So that's our setup, right? I'm going to replace this with an equal sign. And I wanted to equal to 0, so I'm going to move that 300 to the other side. So I'm going to subtract minus 300, and that is going to give me W squared plus 5W minus 300. And that is going to set equal to 0. The next part here is that we are going to find our solutions. So when we're finding our solutions here, we want to, we can either do the giant X or we can use the quadratic formula. I'm going to go ahead and actually jump for the quadratic formula. So let me make more room for myself over here. And let's go ahead and identify, let's go ahead and identify A, B, and C. So my A is the coefficient of W squared, which is 1. My B is going to be the coefficient in front of W, which is 5. And my constant C is at negative 300. So now that we apply it into there, let's go ahead and use the quadratic formula. So the quadratic formula, I know it says, we'll just write W. So W equals negative, we want my B value there. So that's going to be 5, parentheses, plus or minus square root of B squared. So that is 5 squared minus 4 times A, which is 1, times C, which is negative 300. Oops. All over 2A, or 2 times 1. And let's go ahead. Remember, as I break it down piece by piece. So negative times 5, that's just going to be left with negative 5. Plus or minus 5 squared is 5 times 5, which we get as our 25. Negative 4 times 1 is positive 4. Negative 4, my mistake. So yeah, negative 4 times 1 is negative 4. Negative 4 times negative 300 is positive 1,200. And keep in mind that is all over 2. So let me shorten this up so I can move it towards the right-hand side. So I'm going to add 25 plus 1,200 to both sides. And I'm going to see if I can go ahead and take the square root of that, which is, it is a perfect square root. You can go ahead and use the calculator. So when I added and then I took the square root, I get -5 plus or minus. It was, when I added those two, I got 1,225. After taking the square root, I just got 35 over 2. Now again, we do have two answers here. We will have -5 plus 35 over 2. And then this will give us -5 minus 35 over 2. So -5 plus 35 is 30. Half of 30 is 15. -5 minus 35 is -40. Half of -40 is -20. So I have my two answers. I have W, so I'm going to write it here at the top so I can erase the bottom part. W is equal to 15 and -20. Lengthy process, we're still not done. So from here, what we're going to go ahead and do is we test out the interval of it. So the reason why I've kept this up here is because we're going to apply to it, but I'm going to bring that 300 over to the other side. So keep in mind, the equation was, I blocked it off, but it's W squared plus 5W minus 300 less than or equal to 0. So our answers is 15 and -20. So what I'm going to do, we should drop our -20 here. Oops, not -21. -20, and here's our 15. So again, you break them down into 3 sections here. Okay, looks like we had a little hiccup there. So from here, we got 2 answers. So let me go back to writing it out there. It is, let's see, we had W is equal to -20 and +15. And we were plugging it into this W squared plus 5W minus 300 less than or equal to 0. So again, as I was kind of going back over here, so we put our -20 here and 15, and we break them into 3 sections. So I have my purple section here. Oops. Let's do a highlight of that. So here's -20, or that one section right before it. Here's the middle. And let's do this in pink. There you go. So what I'm going to do in red is I'm going to put a value that I can test out. Let's just say, let's put -30 here, because that belongs in that purple section. Again, you can choose any random number except for 20 and 15, -20 and 15. Here I'm going to put 0, and I'm just going to put 20 here. So these are the values. I know they don't actually correlate within the number line perfectly, but those are the values that I'm going to test out into this equation here. And I messed up that equation here. It should be -300. My mistake. So now we're going to plug in those values there. So let's try out -30. -30 squared is 900, positive 900, minus 150 minus 300 is less than or equal to 0. So that's already me at multiply and substituting -30 and for W already multiplying some things out. So we get 900 minus 150 minus 300, we get 450. So the question is 450 less than or equal to 0. Is that true or false? Well, 400, positive 450 is not less than 0, so this is false. So this area doesn't work. Let's try 0. 0 squared is 0, plus 5 times 0 is also 0, minus 300 is less than or equal to 0. Negative 300 is less than or equal to 0. So this area is true. Let's try that 20. So 20 squared is 400. So I'll do it down here. 400 plus 5 times 20 is 100 minus 300 less than or equal to 0. 400 plus 100 is 500 minus 300 is positive 200. Is 200 less than or equal to 0? It is not. This is false. So the only area is true is between the negative 20 and the 15. So right here, our interval or final answer is going to be from anywhere. Our new width can be from negative 20, our variables W, to 15. Now, there's one more thing to consider, is that the width. If I say that the width is negative 20, am I making any sense? I can't walk into Home Depot and say, I need you to cut me this a negative 20 feet of so-and-so, or a piece of wood. They're going to look at me a little bit weird and be like, that's not possible, right? So I think also here to kind of consider, let me kind of erase all of this here, is when they do the interval test, they're going to get the same results as us. So if you click over here, they're going to do the interval test, false between negative, that purple area of negative infinity to negative 20. They got true from negative 20 to 15, and then 15 to infinity is false. The thing is, I can't consider that answer that I have between negative 20 and to 15, even though it works for the equation, we have to consider the context of the actual word problem. So in this case here, we are going to actually rely on that it's going to start at 0 to 15 because we can't count this negative area. So our final answer here is 0 is less than or equal to W less than or equal to 15. Again, the reason why is because this little section of that negative, I can't say that, oh, we can cut it down to negative 15 feet or negative 10 feet, because that's all true within there. Like I said, if I walk into Home Depot and I say, can you cut negative 10 feet of this wood? They're gonna look at me weird. There's no such thing as negative answers in terms of measurement, or in other words, also in time. So you got to be very, very careful when you end up writing that final answer. So let's take a look at this one right here in slide 25. I will help us set up and then I'll let you go ahead and continue solving, but it's pretty much as what we did in those previous ones. So let's take a look at this one. Maya has 50 feet of fencing to make a rectangular kennel for her dog. She decided to use part of her house as one side, the width of the kennel. She needs a minimum enclosed area of 300 square feet. So minimum, right? That's the smallest amount that she's going to go for. It has to be bigger than 300. So let's take a look at this next part here, where she decided to use part of her house, one side of the width of the kennel. She needs a minimum. Let L represent the length of the kennel. Which equation? Okay. So if we consider, here's the kennel, right? Pictures are always worth a lot. Here's the width of so she has 50 feet of fencing. So a total of 50 feet of fencing, right? Now she needs to consider, this is the length. This is the length. Here's the width. And here's the width. But there's one thing to consider. It says she decides to use part of her house as one side of the width of the kennel. So we're not going to include this side. So we need to consider the fence. This side of the fence does not exist because she's going to use part, or Mia's going to use part of her house. So we're talking about the area, right? Because it says that the minimum area is 300 square feet. The thing is, if you look at all your options over there towards the left, we need to multiply the length times the width. Here, we can't use W, so we need to rewrite W in terms of L, or the length. How do we do that? We were given another key information that 50 feet of fencing will make up the rest of that fence. So if I include this length, this width, and this length, that's going to equal a total of 50 feet. So let's rewrite that. Let's just write that equation now. So it's length, oops, my L's are length plus W is equal to 50. So here, let's, again, because we have two variables and we want to go down to one variable, or we're not, let me rephrase that. We're not trying to get rid of W, but we want to rewrite W where W is equal to something of L. So if I have this W here and I have two L's, let me rewrite that as 2L plus W is equal to 50. I'm going to subtract the 2L on both sides to leave that width alone. And now this will be W equals 50 minus 2L. So now I can rewrite the width as 50 minus 2L. Now we can talk about the area and how the minimum enclosed has to be 300. So I'm going to put the 300 here. Minimum amount is that it could be 300, but it has to be 300 or more, right? Minimum is 300. I don't want anything less than that. So I want this to be greater than or equal to. Now, again, when you're multiplying the length times the width, here's your length. And your width is that you're not going to write just W there. You're going to write 50 minus 2L. So now that we have our setup, right, because that's the key important part, setup. So L minus 52L is greater than or equal to 300. Now what we're going to go ahead and do is that you're going to go ahead and continue solving and finding out that interval there. So don't forget that you're going to end up distributing the L first, subtracting that 300 over to get one side equal to 0. And then you're going to replace the inequality symbol with an equal sign. Once you have that equal sign there, you're going to go ahead and continue solving. Make sure you factor out a GCF because your terms you should be able to factor out a -2. So that's already a hint there. And then you're going to go ahead and select. So you are selecting 2, the setup of the equation, which is this one right here. Then you're going to define which interval it is for me. Consider also the fact that if part of your answer, kind of like what we did in the previous example, if your length is going to be portion of it is in the negative area, think of length cannot be negative, has to be 0 or positive. So you want to consider that too when you're solving. So I'll let you go ahead and work on that. And after that, you are done with this tutorial. Again, here is on slide 27. It's a little bit of a summary of what you did with the linear equations versus those inequalities. They're very similar. Just probably that last final step is that you want to consider your inequality symbol, and then you just have to graph. Quadratics, it takes a little bit more steps because you have to check out those intervals to making sure which one is true, which one's false, and you only want the true portion. And that is it for this tutorial.